So in part B, we are told that the farmer grows a large number of apples, 80% of which are eating apples. Both types are picked randomly and are mixed together in this cleaning machine. And we're told that after cleaning, the machine separates the apples that have a weight larger than 140 grams into a separate container. And we select a random apple from that container, and we need to find the probability that it is an eating apple. So what we should do here is make a tree diagram so that we can visualize what is happening. So at the start, we start with a dot, and then we have two options. We either pick an eating apple or a cooking apple. But when the question we are told 80% of the farmer's growth is eating apples. So let's say this is eating and this is cooking. So eating will be 4/5 of the there will be a probability of 4/5 to pick an eating apple, and therefore a 1/5 to pick a cooking apple, because 80% of all apples are eating apples. And then the eating can either be larger than 140 or smaller than 140. And same with the cooking apple. And well, in part A, we have calculated this probability, right? So we have calculated the probability that an eating apple has a weight larger than 140. So that's like 2.5%, or we could also say 1/40. And then we need to do the same for the cooking apples. Luckily, the mean of cooking apples is 140 grams. So if we imagine the normal distribution curve for this, 140 is in the middle and it's symmetric. So on both sides of 140, we have 50%. So weights larger than 140 have a probability of 50%, so 1/2. And then what we need to find now is the probability that we pick an eating apple. And obviously we are only picking from the ones that are above 140 because the machine separated the ones that have a weight larger than 140. So we only need to consider the 140 weighted apples. So this is a conditional probability question. So pretty much what it's asking us is what is the probability that we pick an eating apple given that we pick an apple larger than 140. So the probability that we pick an eating apple that is over 140 is 4/5 times 1/40. And then we need to divide this by the total number of cases we can have, which is simply the probability of picking an eating apple and it's above 140, and picking a cooking apple and it's above 140, right? So these are the only two cases because the machine has already selected the ones that are above 140. So these are the only two outcomes we can have. So we need to divide this by 4/5 times 140 plus 1/5 times 1/2. So that's the total number of cases we can have, or total probability. And what we need to do now is simplify it. So this will be 1/10 over 1/50 plus 1/10. 1/10 is 5/50. So what we have is sorry, this is 1/50 at the top. 5 times 10. So what we have is 1/50 divided by 6/50. The 50s cancel out, and so we're left with a probability of 1/6.